Okay, ladies and gentlemen, let's talk about geometry as a system. Now, first of all, before we talk about geometry as a system, let's define what a system is. A system is nothing more than a set of interrelated parts. Now, those parts can be related in a bidirectional fashion where object A affects object B and object B also affects object A. It could also be a one-way system where object A affects object C, and then object C therefore affects object B. So you have multiple ways a system can be together, but the idea is that all of the components of any given system have to be combined to accomplish a single task. Now, if I have yet another object over here called object D, just because it's in the box does not make it part of the system. You'll notice that D is not connected to either object A, B, or C. And by not connecting it to object A, B, or C, it's not really part of the system. It might be included either physically or logically, but it is not part of the actual function of the system. And of course, the whole point of the system is for it to function. If a system does not function, then there is no point. So, how does that apply to geometry? Well, geometry is also a system. And just like algebra is a system where we have rules, and those rules govern how we approach algebra, how we evaluate, how we solve, how we find values. Geometry also is a system. Now, we're going to be talking about a particular type of system, and that is a system where certain things exist. This piece of paper is actually a very good example of how we're going to start with our basic system in geometry, because we're going to work in what's called the Euclidean system. Now, the Euclidean system was brought up, or at least popularized, by a fellow named Euclid. It's actually built over thousands of years, but Euclid is the one that popularized it. He gets credit for it. You can blame him. What he suggests is that in a system, you have what's called a plane. And a plane technically is not like this piece of paper. It's more like this, where instead of being able to see or have edges to a piece of paper, Euclid's system has no edges. It extends infinitely in every direction. Now you'll notice it extends infinitely in only two directions, this axis and this axis. Now you'll go back and we can make a connection to algebra in that we would traditionally call this a y-axis, and we would traditionally call this an x-axis. Okay, and some combination of the two by moving over and moving up would allow us to move anywhere on this plane. So we have this idea of a plane. We also have the idea that on any given plane that exists, it's only in two dimensions. And on that plane, I can put a location. That location right there is called a point. Now, a point is nothing more than a location. It's like GPS coordinates. It doesn't mean there is something there. It just means that is a place that exists somewhere and on the plane. Now, if on the other hand, I take a number of these points and I put them beside each other, I can start to build something. If I seem to move in one direction only, regardless of what that direction is, I create something, and we're going to go ahead and call that a segment. So it's like a string of pearls. It's like a necklace. We create a segment. Now, if we, much like the plane, make sure that that segment expands forever this way, and it expands forever this way, now we don't have a segment. We have what we would consider to be a line. And that line would move in each direction infinitely. So you have points, you have segments, you have lines. But what if we started with our points, but we only put our points together in one direction and we only went infinitely one way? Now, instead of a segment or line segment, which has a specific beginning and a specific ending, we have a series of points that has a specific beginning, A, goes through some other point. In fact, it goes through infinite numbers of points, and it goes through B off infinitely in one direction. That would, of course, be a ray. If I were to extend all the points together, now I get a true line. So these are just some of the basic components that are going to make up a Euclidean system. You'll notice everything is done on a piece of paper because in the Euclidean system thus far, we're only working 2 dimensions. Now, I can, on the other hand, have a Euclidean system that does indeed work in 3 dimensions. So I have 1 line, I have 2 lines, and now I would have 3 lines, and we have something that works in 3 dimensions. So if we begin with nothing more than a solitary point, we can build from points to rays, or points to segments to rays to lines, and from lines we can go from there. But what we're doing is we're building an entire system, and that system has a set of rules. The entire point of your geometry class is to learn all the rules of the system so that you can work within that system. You can't use rules that are not part of that system. That's just like having a rule or an object that you have included but does not have any bearing on the remaining pieces. Okay, now they also have rules where one system may connect to an entirely different system, and some of the rules may apply where others may not apply, and we will get to that as we move forward. But that's the idea of a geometric system. Your job is to learn all of the parts of the system, and the parts of the system that are going to be important to us are definitions, theorems, postulates, and corollaries. Corollaries, there may be 2 L's in corollaries. You're going to need to know the definitions, theorems, postulates, and corollaries, and there's going to be a bunch of them. So what you need to do for tonight is you need to define those 4 words. Your homework is to define those 4 words. And while we're at it, I also want a definition of a system. Dope. A point, a line, a ray, a plane. And you will turn in those definitions or have them ready for discussion in class.